So today we have a 915 that we're going to do a teardown and inspection. It came to us with the SC engine. Owner just wants to see what it looks like inside. It also looks like it's been leaking quite a bit. We've given it a quick wash outside, but now we're just going to tear into it, see what synchros look like, bearings, gears, and quote the whole job. Not super disgusting. Not all furry. So pretty much the same as the engine. When I got everything apart, looks like this has not had a lot of oil changes. The oil that came out of it wasn't too bad. It's been sitting, but a lot of debris and gunk sitting in the bottom. Not a lot of metal though. Quick look over the gear sets. I have not disassembled yet, but a quick look at dog teeth and synchros are not that horrible. Just everything is really gunked up. Right now, with just a quick look, looks like dog teeth will be all right. Sliders will probably be okay. Still need to get that apart and cleaned up, washed up, so I can do a true inspection. One problem that we do have that is going to need a lot more work is our pinion bearing here. Is actually, this should be a press fit. We do have a video on this stuff for more detail, but this one actually has side-to-side movement, so it's actually causing that pinion shaft to wobble and create an egg shape in there. The bearing won't just slide out, and I suspect just because there's some damage to the aluminum. So what we're going to have to do on this one is machine a new sleeve into this area and then press new bearing shells in to rectify it. This is a big deal. If you don't take care of this correctly, then you're going to cause damage to the pinion shaft and crown wheel, which is a very expensive piece of equipment to damage. And also it's going to make noise as well. So I have my front differential case back from the machine shop, and what we did here is both of these bearings were spinning. In fact, the pinion bearing had egg-shaped that housing to where you could grab it and literally move it up and down. And so what's been done is these bores have been re-centered to each other. They've been bored oversized, and they've instilled a steel insert which is just around the outside of the bearing on both of these bearings. And this is just like a valve seat and a cylinder head. It's a much tighter clearance. They heat the case up, press in the piece of steel, and then remachine the steel to suit the bearing interference tolerances right here. Press in new bearings and everything's all set up. So we've also machined this surface right here. This is where our shim pack sits for our differential pinion depths. And we'll be resetting that up anyways because of new bearings, and it may take 0.1 of a millimeter more in shim face right there. I've also retapped all of my stud holes. We've had the studs out for all the machine work, and I'm just starting to put the studs back in and get the case reassembled. I've also thoroughly cleaned it, and this is one point that I wanted to touch on. Whenever you get something back from a machine shop, it is never assembly clean. It always has to be gone through and re-cleaned. There's always machine stuff and media and bits and pieces in there. So if you're the guy assembling it, do yourself a favor. Even if it looks clean, clean it again. I also have cleaned up most of the transmission, side cover, back cover, clutch shaft. I have new clutch fork. These are really common. They wear out. You'll see a big ridge right there. We have our new bearings, clutch shaft seals, pivot seals, synchro rings, and right now I'm about to start disassembling our input shaft. I have it up into our assembly shaft holding fixture so I can undo the nut, disassemble everything, wash it, disassemble my synchros, go through and change all the worn parts there. Same with the pinion shaft. We have it sitting right here. It'll be next. We've got all of our old bearings that we're not reusing. And this one, the shifting side of the transmission was not really a major concern. The wear on the synchros is average. It was more the lack of oil changes that's necessitated going through this one, and the issues were more bearing related than anything else. We can fix him. So I have my input shaft. I've just disassembled it. Everything's still oily and greasy. I just need to go ahead and clean it up. Bearings just going straight in the trash. We're not reusing any of the bearings on this job. Synchros, not super horrible. We're going to change them just because we're in here. They are showing a little bit of polishing and some lubrication failure. You can see where some of the stuff's starting to pick off, but certainly not the worst I've seen. As far as gear wear, taking a look at the sliders, actually in not bad shape at all, which is good. We'll be able to reuse these nice and sharp on the points right here. So we're just going to get all of this cleaned up. I'll do the input shaft first. Doesn't matter which shaft you do. You can do input or pinion. That's up to you. It's just the first one I grabbed. So we've just got our new synchro sitting in. We'll just put our circlip back on. And the trick with these is holding the synchro in because it's going to be under some tension. And just making sure it moves nicely, which it does. And that's it. Ready to go onto our gear set. And our spider is going to come in next. Just like that. So when you're reusing the sliding rings, we want to make sure we get the old remnants of synchro material out from between each one. So that usually means coming in here and scraping it to get it out of there. And this is just like any drum brake assembly, where you get to build up brake dust because the synchros are essentially brake bands. And this is where the debris ends up caked in on the slider. So now I've got my bearing, my radial bearing on. This is an annular bearing. This is what's supporting the input shaft. All of our gear sets are on, new synchros, sliders back on, all cleaned up. Everything is dry. There is no oil in here, and that's very important. When you're tightening this up, it's different than putting engine components together. The reason for that is what they want is when you torque this nut, that all of these inner components, so the inner races and the gears, all they want those to really lock up tight against each other and not move. If you have oil in there, there's a chance where the inner races on these bearings can spin, which would damage the shaft and shorten the life of the transmission. This is a new factory Porsche nut. These ones do come with a line of Loctite already pre-installed. You still are going to peen it. There's a peen spot right there. And I always use new nuts just because the old one is peened in place. You can get another bite out of these if you absolutely have to. These are fairly cheap. The last thing I've got to do here is I'm just going to torque my shaft. I got a special tool holding it. And the torque on this one is, I forgot, 160 to 180 Newton meters. I went at 170 right in the middle. And once we're torqued, I've just got to peen the nut right here. And then the input shaft is pretty much ready except for the rear bearing that I've got to install. So next I'm going to disassemble our pinion shaft, clean everything up, replace the synchros, put on new bearings, and put it all back together so we can start setting up our transaxle. Okay, so I've got my pinion shaft all pressed apart. I'm just cleaning up everything. Same thing as the input shaft. Going to replace the synchro bands on first and second gears. Clean up the sliders, scrape it. All the dog teeth look good. Once again, changing the synchros just because we're in here. The main problem with this transmission was bearing related. Okay, so there's our pinion shaft all back together, new bearings on, and synchros. The next step in this transmission is setting pinion depths. So where I am at right now is shaft is all assembled. I've just put the reverse selector hub and the bearing spacer on to the shaft so I could torque it to 250 Newton meters. I'm starting with the original shim pack, but we do have changes here. We have the bearing race that has been remachined in the case. They've also flattened this surface because it has a bunch of high points, which is very common. And we also have new bearings. So starting with the original shim pack is just to see where I'm at. I'll get a depth. The face of the pinion on this one was plus 0.33 of a millimeter. So I'm zeroed at 66.63 on my gauge. And I'm about to put the top cover on and measure what our actual pinion depth is now. Okay, so right now, this is 0.18 of a millimeters too deep in, and that means the pinion is in way too far. Our 0 point is right there. So as I'm moving my dial gauge or my pointer across the front of my pinion, it's measuring how far in that pinion is measuring. If we were at the 0 point, I should be able to come up to it. Just like here, I can see eases up to 0.18 and then starts to come down. That's when my shaft is perfectly pointing straight at the center of the pinion. So I need to add a shim that's going to get me as close to 0.18 of a millimeter. I'll pull it out, measure the thickness of these, and see what shims are in there right now, and see the best way to achieve this. All right, so with a shim size required of 0.18, if we used a 0.15 shim, that's going to put us right on the cusp of our plus or minus 0.03. So using a 0.2 shim, and here I'm just measuring it, I got 0.196. This is going to get us the closest to where we need to be. So I'm going to pull my pinion, put in the shim, and remeasure and see where we're at. I'm just adding my 0.2 shim, and we can see in here I've rotated. This is what's happening when I'm turning my pinion measuring tool, I'm bringing that pointer to measure on the front of the diff pinion. Just turn that away for right now and put my pinion back in. So when I put in the 0.20 shim, we were just outside of the tolerance. And this often happens with moving stuff around. What ended up my reading that I got was 0.04 of a millimeters too far out. So I put the 0.15 shim in, and measuring on that one when I come in, it's right on the plus side of 0.03. It's actually a hair under 0.03. It's like 0.95, oh sorry, 0.29, somewhere around there, 0.29. But the long and the short of it is it's inside tolerances with a 0.15 versus the 0.2 shim. So now I got my pinion depth and shim pack set here. I'm going to pull all of this out. I need to set up my differential next. I need to set the preloads first because we are putting new bearings in. Well, we've obviously got new racers in here. But I'm going to be resetting all of that. That needs to be done with the pinion shaft out. Then the last thing I'm going to do is set backlash. Now that is where I'm going to put the pinion shaft back in to measure backlash, and backlash is the clearance between the ring and pinion gears. All right, so before I did a whole lot here, all I've done is I've put the same shim pack in. This bearing had spun on the original differential, so I put in a new shim pack here just to replace the one that was all burnt out. And I'm just going to do my preload specifications first. So I got bearings installed, shims installed. I'm going to put the top cover on and measure my bearing drag. There's two ways of doing this. The most accurate way is to actually measure it. The other way is to use a feeler gauge underneath the cover. So let's get this on and take a couple of measurements. So I just want to settle the bearings first. So I'm just turning them backwards and forwards. Doesn't feel bad, but we'll put a torque meter on it and measure the drag in just a minute. Looks like that is right at about 25 inch-pounds or 4 newtons, which is pretty close to where I want to be, but I'm just going to check the spec. Okay, so the spec on drag is 3 to 4 newton centimeters or 26 to 37 inch-pounds. We're right at 26 inch-pounds. That's for SKF FAG bearings, which is something that I haven't used a lot of. Right now in here we have an SKF bearing, and so we are right on our drag. We're right at that 26, so our specs are good. FAG bearings, if it's got a higher preload, it just means that that bearing is going to wear in a little bit more. The whole purpose of a preload is to allow for bearings to settle, and I'm pretty happy with what we got. So now we're going to put our pinion shaft back in, lock everything up, and measure backlash. So the first thing I want to do before I even put a dial gauge on and try and measure it is I'm just going to rotate the pinion all the way through. And you'll notice here on my pinion that I've got backlash, just putting it in. You've got to be very careful as you tighten the pinion shaft in or tighten the crown wheel down, either one, that it doesn't bind up hard against the pinion shaft and the crown wheel, because you can damage them, you can chip them. Then you're going to be replacing those shafts. So it already feels pretty nice right here on my pinion, but I'm going to rotate it through at least 360 degrees of the crown wheel or the differential rotation. Make sure there's no tight spots anywhere. And I'm feeling for what's happening with each one, and I'm going to go both directions as well. Just make sure there's no weird clunks or tight spots that I can feel. And I still, at each point, I still maintain a similar backlash. Now moving it with my hand doesn't give me any hard numbers, but experience tells me I'm going to be pretty close in the ballpark. And that feels good all the way through. So the next thing I need to do is I need to set my distance here to be able to measure the backlash. And what we're doing is we're measuring, if we imagine the pinion sitting here and the crown wheel, we want to be, this is going to be out right in about the center of those gears. It's a measuring point. This is an adjustable piece from Porsche, and that allows us to measure the backlash right at the gear face. So we're going to be rocking this part back. We're going to hold our pinion shaft, and we're going to rock our crown wheel back and forth. This into the night. So I'm just taking all of my torque off the pinion shaft so I can assemble my input and pinion shaft into the case, because I need to be able to lock up the pinion shaft to measure backlash. So I can't do that with it just in by itself. So I've got my input shaft and pinion shaft installed into the case and tightened. I put all my studs back in. Right now I'm going to adjust my selector fork. So I just have the fixture on here that supports the selector shafts. I have all my detents installed, new plug back in on the top there, and I'm just going to adjust these and tighten them. So we want to make sure these have quite a range of movement where they can kind of swing around. You want them nicely centered in between the two synchros. And then we're going to torque our bolt. Make sure nothing moved. Same for our third, fourth selector. And then lastly is the actual part that the selector gets activated by. To do this, I'm going to roll the transmission over so I can see it. So this piece here is our final selector piece. It has to be adjusted both this direction, and you want about 2 to 3 millimeters clearance off the shaft. If you have it sitting hard up against there, it's going to bind. All right, so should be nice and aligned here, which it is. When I rock it, it doesn't hit anything. These will rattle when the car is running. This is the famous 915 gear rattle. It's the selectors. So we're all set here, ready to put the back housing on, and then I can lock up the transmission and check my differential backlash. Okay, so we're going to tighten the pinion shaft back up. This one's pretty tight. The spec is 240 to 260 Newton meters. I'm going to 250, right in the middle. And then what I'll do is we've also got to tighten the input shaft. So I'll need to put fifth gear on to torque it up to do that. All right, so I've tightened the input shaft to 120 Newton meters, and let's see if our roll pin drives in, which it does. Okay, now I can put all my fifth gear and reverse back on. Okay, so I've locked the pinion shaft with a Porsche special tool. And I'm just going to measure the backlash between my gears. Right now I'm measuring 0.2 of a millimeter, which seems a little bit high. But I'm going to pop the case off and look at what the desired spec is that'll be engraved on the crown wheel. So the desired backlash on this one is 0.16. I'm measuring 0.20, which is a little on the big side. Let me see what the total is. Okay, so when I first measured my backlash on the ring gear, I had 0.20, which is outside of the maximum Porsche spec. It's 0.04 off of the desired. Now, the desired number you get is 0.16, and that's engraved on the ring gear. And we were at 0.20 is when I measured it. So what I did is I pulled the ring and pinion back, or pulled the ring back out. My original size on the speedometer side was 3.1, and I had 3.1 on the back side for a total of 6.2 millimeters of shims. So to move this gear closer, what I did is subtracted 0.1 from this number, which took it from 3.1 to 3 millimeters even. But then you've got to put that 0.1 back over onto this side to maintain the bearing preload. So this number went from 3.1 to 3.2 millimeters. So I've done that on the ring, and I've reinstalled it back into the case. And now the number that we are getting is 0.14 of a millimeter. Still not this ideal 0.16, but it's still in that factory usable range of what Porsche says this is where the ring gear backlash has to be. So I'm just going to re-zero my pointer. I'm locking up on my transmission. All right, so if we look at what we're getting when I'm snapping that ring gear back, we're right on 0.14 of a millimeter. And that's exactly where we're going to leave it.
So loose. Yeah? 40 newton meters.
Well, that wraps it up for this transmission. It's ready to go back into the vehicle, and fresh oil, ready for another 100,000 miles of use.